Do you suck at beer pong? Or are you actually quite good, but always get teamed up with someone playing below par? If that's the case, I've got the solution for you. This. Is the Apollo Mark II. Oh my God. Hi, my name's Sean. I'm one of the engineering dads. Now, I know what you're thinking. Apollo Mark II. Does that mean this is the second time you've built this? Or is this actually French and it's Mark II is the last name? Yes to your first question, but no to the second. That was a dumb question to ask. Apollo Mark II is a descendant of the original Apollo project, which was something that we used to kick off the Engineering Dads channel. 2 years ago, James and I created a YouTube channel where we wanted to create engineering projects. James likes to call us the founding fathers. So we started this channel back when we were both at university, and as engineers going to university, there was quite a bit of drinking involved, and we played quite a bit of beer pong. And so we decided to try and kick off our channel with the competition, so he could build the best beer pong launcher, for which the Apollo Senior project was developed. The rules were simple: had to be recycled materials, and 2, had to have a total budget of $50 or less. Did I mention we were at university? Me goreng is king! But since then, James and I have learned a lot. 3D printing, woodworking, electronics, plumbing. There's over a dozen videos on techniques and skills that we've learned. Go check them out if you can. And so given all that experience, we decided to go with the competition again with less constraints, and for which I created Apollo Mark II. And there are a lot of improvements to this design to the previous one. But every single one is related around accuracy. Now, looking at the design of the two, there are a lot of similarities and differences, but let's firstly start with the similarities. Now, between the two, we have a tube designed for launching, a potential energy storage device, usually a spring, or previously it was a rubber band, an axle of which we can change the angle of attack, and a mechanical trigger system. Ow. And an electronics box for firing. And so you can see how there's elements of Mark I that have gone to Mark II, the better Mark II harder. But then there was a lot of major changes between the previous and new design. Now the first one is this here 3D printer, which meant I could print pretty much every single component besides the electronics for my device. The tube itself is perfectly situated for a ping pong ball to slide in and out of. The motor sits perfectly onto the axle, enabling that rotation. The trigger mechanism is completely my design. I now have put a dial on the side too, so I can exactly tell what angle I'm firing at. With the right settings, it can be both super light and very strong, which, as you can tell from my design, it is. Now, stepper motors. These little bad boys over here. Now this is a low power version, so it's super fine for my design, but stepper motors are really, really valuable. Unlike an AC or DC motor, which you see in electric vehicles or elevators or anything else that spins around realistically, a stepper motor moves at very small gradients at a time, at small steps of rotation, where the name comes from. Now they are very loud and they're very slow. Those are the cons. But the good parts are incredibly accurate to where you want it to go, which step you want to do, and they're quite strong in holding that position. So for a device that needs to only go 30-40 degrees, that's perfect for me. And the final adjustment that I've made is including this IR remote, which I'll give you a closer look at afterwards. And the way it works, it can connect to this box, and I've pre-programmed a lot of settings just for this device. For example, now it's hard to tell on this remote, so I'll pull up a little schematic of it, but you can see there's buttons on the bottom here, 0 to 9. Now these are actually programmed with the degrees it needs to rotate as a multiple of 10. So if I hit 0, nothing happens because it's at 0. If I hit, for example, the 5, it'll then rotate to 50 degrees angle of attack, like such. And furthermore, I can go straight up to 90 degrees, straight up. And if I hit 0, I'll go back to 0. There we go. Completely remote controlled. Now, it's not all that useful because if I shoot at 90 degrees, it's going to either possibly sink my own cup or even worse, cause blunt force trauma when the ball comes down and hits me in the head. And also, we're not bowling here, so there's no point firing it straight either. So it's, but it is really quite useful. Addition to 2 is the plus and minus, which means I can make very minor adjustments to the angle of which I want to fire at. The black buttons there do the exact same. Now that red button does fire the device, but so does the green button. And put that all together and you get this. a semi-accurate ping pong launcher with a beautiful and repeatable arc of fire. It honestly is enough to make a grown man cry. When I say a grown man cry, I mean me. This is beautiful. And it's not perfectly accurate. And by semi-accurate, it means that once I have it fully calibrated of where I know it's gonna land, I can hit that target again, again, and again, and again, and again. I know for a fact if I get a tight grouping and I keep hitting around the cups, there's a pretty good chance that I'm gonna go home with this trophy. Oh, did I forget to mention the trophy? Yes, we actually made a trophy for this competition. Last time it was purely bragging rights, for which I dominated. But this time, clean slate, we have a trophy that will go to the winner. Now, I know for a fact James in the last 2 years has really developed in terms of his engineering capability. I know he's going to bring stiff competition. So I'm looking forward to the competition, for which we will be recording and posting onto this YouTube channel in a week or two probably. So to make sure you're in the loop, please subscribe, and if you can, drop a like. Anyways, I'll see you in the next one.